Next up, we'll walk through the contract upgrade and storage collision monitors. The contract upgrade monitor fires automatically whenever the target contract is upgraded. It triggers automatically. The storage collision monitor, on the other hand, kicks in during an upgrade to check whether the contract's old and new logic contracts have any storage layout conflicts. This typically comes down to smart contract developers not fully understanding how Solidity compiles or how the EVM works under the hood, and this kind of issue can lead to serious exploits. Let's walk through a real-world attack to show how this plays out. According to the blog post analysis, the root cause of the SHADA Capital exploit was specifically this. When EF Vault's logic contract was upgraded, two new storage variables were added, asset decimals and whitelist. But when a logic contract is upgraded and new storage variables are introduced, you need to account for backward compatibility with the old contract. Clearly, the developers at SHADA Capital missed that. The newly added asset decimals ended up occupying the old version's storage slot for max deposit. And max deposit, in turn, took over the old paused variable slot. As a result, the contract's behavior after the upgrade became extremely unpredictable. For example, when reading asset decimals, it would return whatever value max deposit had previously been set to. Say, 5 trillion. And as we all know, asset decimals is normally a very small number, something like 8 or 18. This can have devastating consequences, like the $5.1 million loss from this attack. Similarly, let's pull up that transaction, copy the target contract address, and import it into our system. Import address. Click Add to Import. You'll notice that Phalcon Security has detected this address is an upgradable proxy contract, so it automatically created both a contract upgrade and a storage collision monitor for it. And it set the contract upgrade monitor's severity to Info, while the storage collision monitor's severity was set to Critical. Let's click OK. Over in the monitor section, you can see the two monitors that were automatically created. Let's open the contract upgrade monitor first. Whenever EF Vault is upgraded, this monitor will automatically fire an alert. Now let's open the storage collision monitor. The trigger condition here is, when the contract is upgraded and we detect a storage collision, an alert fires. Once monitors like these are configured, our system will watch the contract around the clock, 24/7. But to make sure the monitors we've configured are working as expected, we can use historical transactions to backtest the monitors. The test kit feature lets us use historical data from archive nodes to re-execute past transactions and simulate what happened during the attack. So let's copy the hash of that upgrade transaction. Click Create Test Transaction. Paste the hash. Click on the transaction. Run test. Give it a moment. Alright, the backtest is done. This transaction triggered both the contract upgrade and storage collision monitors. Let's click into each of their alert details. In the contract upgrade alert details, you can see the proxy contract's old logic contract address and the new logic contract address. In the storage collision alert details, we can see that Phalcon Security successfully identified the specific variables involved in the storage collision from this upgrade: max deposit and asset decimals. This matches the blog post analysis exactly.